Okay, so in this short video, I'm doing a review of having fractions as exponents. To start with that, to use this, sorry, I'm going to start, the rule we're going to base this on is knowing that a variable, or not any real number, I'm using my variables as a, raised to a power, and then that quantity raised to a second power, what you end up doing is multiplying the powers. And I talk about this property in my previous video where I review the exponent rules. So based on that, notice that a couple things. I mean, we know that the root of a 2, for example, we know that the answer is 1.41, similar to something like that, sorry, approximated something like that. But the property we're going to use here is that if I square this number, right, you get a 2. That's what it means to be square root of 2, right? It's that if you square that quantity, you get a 2. So what I want to compare this with is, what would it mean to have cube root of 3? Sorry, cube root of 2. So what I'm saying is that if I cube this quantity, whatever that is, I should get a 2, right? But using this property that I told you works over here with exponents, that should also be true if I had something with like 2 to the 1/3. I'm just throwing it out there. What if I had 2 to the 1/3? Well, it's a number that if I cube it, I certainly would get 2 again, right? Because using this property up here, the highlighter in the corner, my m is the 1/3, the n is the 3, you multiply the powers, and when you multiply 1/3 times 3, you would get 2 to the 1, so 2. Right, so I just showed two numbers, cube root of 2 and 2 to the 1/3. There are two numbers whose cube is the number 2. So it's a little bit of overkill, but a little bit of an assumption, but these numbers should be equal. There's something to say here to be carefully saying that it's the unique number that does this property, but take my word for that. It's the only number that does a property. So cube root of 2 is the same as 2 to the 1/3. And there's nothing special about this example, right? If I give you any example, if I say 3 to the 1/5, well, it's going to be the same as 5th root of 3. I wrote it in the back order, sorry, in the reverse order this time. It's going to be the same as 5th root of the number 3. Why? Because if you raise this to this power, you get the same as if you raise this to this power, to the 5th power. In both cases, this is just using that this is like the definition of the cube root of a number, or the 5th root, sorry, that you will recover the number. And over here, you're using the rule that's up there in the corner, where you multiply, so you get 3 to the 1. So my rule that I'm saying right here is that my new rule, or fractional exponents, means that a number with a fraction like this is the same as the nth root of that number. Okay, that's my rule. Now, one last thing before I finish this video is I want to say, what if we combine two things like this? What if I had, can I have a number 3 to the 1/2, but then I also might have it to the 5th power, right? So this means, if you want to write it in radical notation, this is the 5th root, sorry, the square root of 3, but then you're raising it to the 5th power, right? Now, using this rule again, the rule is right there in the top corner, I can multiply these powers here, and 1/2 times 2 is just 3 to the 5/2, right? So 3 to the 5/2 is going to be the same as this quantity over here, as square root of 3 to the 5th power. But something interesting by seeing it this way is that I could have also written this backwards. I could have also done the 3 to the, sorry, I wrote it backwards, not that backwards. I could have written 3 to the 5th power and then the power of 1/2, correct? Because if I multiply 1/2 times 5, it doesn't matter if I multiply in this order or if I multiply in this order, 5 times 1/2. But written this way, I could get the square root of 3 to the 5th. So notice that what I'm saying is that these two quantities are the same, right? So I have this, it's not an ambiguous way to write anything, but if I have a number to a fraction with m over n, it's the same as, I could put the n as the fraction as the denominator part goes into root, and the numerator part can be written as a power inside. Okay, so that's my rule for fraction exponents and explaining how they work.